remarks for today, and he's entrusted me to deliver this presentation to you guys, the government officials. So good day, and let's move on. For today, I will first be discussing what are rational functions and how did we use it. So rational functions are quotients of polynomial functions. This means that rational functions can be expressed as f of x equals p of x over q of x. This is where p and q are polynomial functions and q of x cannot equal 0. The domain of a rational function is a set of all real numbers except the x values that make the denominator 0. Moving on. So we applied it in the field of architecture. As you know, Mr. Elias is indeed a wonderful and smart architect. So moving on to the given. Okay. So the given is h of x equals a times the quantity x plus b over c times the quantity x plus d. So x represents the seismic resistance factor, a composite score considering factors like building materials and structural reinforcement. So A, B, C, and D are constants that would be determined based on building codes, local soil conditions, and desired safety margins. Forgive my voice as I have a cold right now, but moving on. So this is Mr. Elias's final output for the rational function. This is each of x equals 14 times the quantity x over 2 times the quantity x plus 1. So a equals 14, b equals 0, c equals 2, and d equals 1. That's why it's only 14x instead of 14 times the quantity plus the quantity b. Okay, so if x remains x, it implies that the seismic resistance factor is constant. So it depends on the seismic resistance, the value of x. It depends on that. Okay, moving on. So this is the example that I wrote for today's session. So if the seismic resistance is 4, this is what it would look like. So each of the quantity 4 equals 14 times the quantity 4 over 2 times the quantity 4 plus 1. So down below, you see, let me zoom in, the second layer, h of 4 equals 14 times the quantity 4 over 2 times the quantity 4 plus 1. So moving on to the third layer, 14 times 4 equals 56, and 2 times 4 equals 8 plus 1 equals 9. And that would equal to 56 over 9. So 56 divided by 9, it would equal 6.22. Okay, so if x is consistently equals 4, the townhouse height will consistently be approximately 6.22 meters. So the higher the value of x indicates better seismic resistance. So that is why the final design of the housing would be a two-story household that has um, very a very modern design. So now let me move on. Forgive me. Okay. So if we graph Mr. Elias's final formula, which is h of x equals 14 times the quantity x over 2 times the quantity x plus 1, this is what it would look like. So as you can see, it is not a constant function. Now, let me just discuss to you the graph, what it indicates. So as we see on the graph, the domain and the range are all real numbers except for x equals 0. and the vertical asymptote is x equals 0, and horizontal asymptote is y equals 0. So the x-intercept is not give cannot be seen there, and y-intercept is also not there. Now let me discuss to you the conclusion. So let me just read to you some notes Mr. Elias gave me for the presentation. So the implications of a constant seismic resistance factor, consistent townhouse height. If the seismic resistance factor X remains constant, the calculated height H of the townhouse will also remain constant. In our example, if X consistently equals 0, it equals 4, forgive me, the townhouse height will consistently be approximately 6.22 meters. So, with that said, the final height of the townhouses would be 6.22 meters. But of course, it will vary depending on the demand of the newcomers if this will still be adjusted. So for now, let us base from this formula. Okay, now moving on, unchanged safety margin. So maintaining a constant X suggests a consistent safety margin against earthquakes. The townhouse is designed to withstand a specific level of seismic activity, and that level is not being increased nor decreased. And the final statement he wrote here is potential limitations. If building codes or seismic hazard assessment change, keeping X constant may no longer be appropriate. A re-evaluation of the seismic resistance factor might be necessary to ensure the building remains safe under updated standards or in light of new information about potential earthquake risks. So, again, this example is not consistent. It may vary in the future because everything changes, and we cannot predict nature to stay constant. So, for now, let us again refer to this final formula. H of x equals 14 times the quantity x over 2 times the quantity x plus 1. Okay, now finally the conclusion. So in the context of building design and earthquake resistance, this function could represent the relationship between a building's height, which is x, and its seismic resistance, which is h of x. And an important note to this presentation is this is just a simplified model, and an actual seismic resistance depends on numerous factors. So for this presentation, Mr. Elias only wanted me to give you an overview of his potential in this field, because if he used more complex examples, many might not catch up because of his brilliant mind. So with that said, thank you for listening, everyone. And I hope that I gave you a great overview of Mr. Elias's final plan for the building of housing for the newcomers. And of course, we are so happy that Fjordland is finally getting the recognition it deserves. And we thank you all, government officials, for giving us this chance, this opportunity for getting Mr. Elias in this project. He is ecstatic, and we have been busy and will continue to be busy until the finalization of the houses. And I hope that the houses will be a sustainable way to keep our citizens happy and safe in their homes, even with the high seismic activities in our area. And that's all. Thank you all, government officials, and I hope you stay safe and you got yourself with Mr. Elias's back. So again, this is Jane, Mr. Elias's junior assistant, and I hope that you've learned a lot of things from me. So thank you. Until I see you again. Bye.